So, hello everyone, myself Ayan. I will be the trainer for this Cisco SD-WAN course. So, we are starting this Cisco SD-WAN course, which is very basic to advanced level. And this will be a weekend batch wherein we will be having our lectures on Saturdays and Sundays between 5 p.m. to 7:30 p.m. IST. Once we have this session, just in case if any one of y'all are unable to attend it, we will also be recording it and putting it on the portal so that you have the access, and this access will be provided to y'all for lifetime. There is no specific duration, unlike others. We provide it for lifetime. So one important thing, first four lectures are free for everyone, and after that you'll have to enroll. In case if you all want to learn about SD-WAN, you'll have to enroll for it. Okay, so let me quickly show you all where you will be getting the recordings and all. Okay, so there are links that I'll be sharing to you all. This is the Sianets portal. Okay, so all the courses are listed over here. We will be creating one new course for Cisco SD-WAN, and those who have enrolled for it will be getting the access for it. You can log in, you can get into that particular course, and like just like this, you will be having the videos for it. And if there is any other documents that is necessary, we will be posting it over here as well. Okay, and there are two other YouTube channels where you all can head over and uh, take a look at the networking concepts, be it security, Azure, Wireshark. There are many networking concepts that you all can clear from these YouTubes. I will paste these links once the session is over. Okay, so this particular course is Cisco Viptela ENSDWI 300415 is the code for Cisco Viptela.
Ayan, I think it's your screen is not coming properly, right? So, are you sharing something? You have shared this YouTube one, na, right? Where you are writing.
Yes, I've shared my
Okay,
screen.
okay. Okay, continue. All these recording,
So,
guys, we will share YouTube and everything. Okay, my team members, he will take care.
so ENSDWI 300415 is the topic, is the course code for Cisco Viptela SD-WAN. So, why actually do we need SD-WAN? So the important question is why SD-WAN and why actually we need it. So SD-WAN itself stands for Software Defined Wide Area Network. As the name suggests, we uh, we will be managing the WAN edge routers using software defined approach. So slowly and steadily, everything is moving towards software defined networking. So SD-WAN is one such concept. Okay. So when we talk, I mean, what exactly SD-WAN does? So if we go back in time, we have some wireless networks. So as of now, the wireless network is being managed by the controller. So we have one controller. Let's say we have this as our controller, and this controller manages multiple access points, right? Via graphical user interface. So this is SD-WAN is also similar to this setup wherein the wireless controller manages access points. In our case, the SD-WAN controllers will be managing wireless WAN edge routers. Okay. So apart from this, Cisco provides two types of SD-WAN architecture. One is Meraki, and the other one is Meraki. Okay, 1 second, something is wrong with my stencil. Hold on.
Better you can start the whiteboard and use that whiteboard.
Sorry, can I ask when you speak, Ayan, there is a background noise from your
Okay,
end, the mic or something. You need to check.
lovely. Do you still have that background noise?
Yes, a bit it's coming.
It is still coming.
Yes, yes. I think your mic is like very close to your mouth.
Okay.
Yeah.
What about now?
Yeah, now it's better.
All right. So just like we have other, I mean, Cisco offers two types of. Cisco offers two types of SD-WAN architecture. One is Meraki, and the other one is Cisco Viptela SD-WAN. The difference between these two is Meraki is designed for small organizations wherein they do not have many sites. And when I talk about Cisco Viptela, it is designed for large scale organization. So each vManage controller can manage around 2000 WAN edge routers. Guys, give me one moment. There is something wrong with my stencil. Give me one moment.
Yeah, you can just close this particular, no, this Epic pen. Just close it. Sometime it behaves like like that. No, no, there is a exit button. There's an exit button. In the, no, no, not here. Into the same place, there is a down, right? In front of these colors. Yes, click here. In menu, click and just close. Yes. Now reopen it. Sometimes it happens. I know.
Seems something is wrong with my laptop itself. Just like we have the WLC wireless controller to access multiple access points. With wireless controller, we access multiple access points, right? So similar to this, we have SD-WAN controllers. There are three main controllers which I will be talking about in detail in later on in this session. So with SD-WAN controllers, we manage WAN edge routers. Okay, so just this is similar to the WLC and the other TNEC, wherein we manage access layer and distribution layer switches. So Cisco offers two type of SD-WAN fabric. One is Meraki and the other one is Cisco Viptela. So Meraki is designed for managing small and mid-size networks, wherein Cisco Viptela is designed for large scale networks. So this is the two difference between the SD-WAN fabric offered by Cisco Meraki and Cisco SD-WAN Viptela. Okay, so what exactly, why exactly we need SD-WAN? If we go back in time, let's say I have a branch in Mumbai and the other branch in Bangalore. This is my Mumbai branch and this is my Bangalore branch. If I want to connect these two branches, there were we used to lease lines from the ISPs. So these lease lines firstly were very expensive. Secondly, let's say if these lease one of the we let's say we came across any issue with these network, these lines, so there were cables, there were fibers that were installed between these two branches which used to connect them. And if we came across any issues with this links, the downtime was high because the troubleshooting to identify where and what exactly went wrong, to identify that, it was time consuming. It used to take a lot of human efforts, and due to these two reasons, it was the troubleshooting was difficult, and due to the troubleshooting was difficult, the time consumed to up to resolve the issue was very high. So firstly it was very expensive, and secondly the downtime was very high. So later MPLS technology came into existence. So with MPLS, we can connect, we can have a hub and spoke topology. We can connect multiple routers with this DMVPN technology. But this was also very expensive. This technology is also very expensive, and even today it is being used into the networking industry. So it is where the infrastructure requires dependency of the network, we suggest to use MPLS network. And even today, most of the branches have one MPLS and one internet connectivity in the network. So MPLS is also expensive, but yes, we require this technology in today. Later, internet was also one of the technology which came into existence, but with internet we have many hackers into on the internet, so it does not give us the security of the connectivity. Apart from that, with internet we did not have any SLAs. Let's say I have a let's say this is one of my branches. and I want to access the servers which is hosted in the data center. And these servers are, it needs low latency network. So if I use internet, it does not provide SLA. Apart from that, it also does not provide security. Even though it was cheaper, it does not provide SLA and security. To overcome the issue with internet, IPsec was introduced. IPsec. What IPsec does is, IPsec stands for Internet Protocol Security. What IPsec does is, it it creates a tunnel on this link to provide the security. But even though it provides a tunnel, it does not give guarantee of the SLA. Apart from this, it, let's say I have 50 such branches. It is not feasible to do configuration on each on every branches about the IPsec. So all this issue with related to internet, lease lines, IPsec were resolved via SD-WAN technology. Now let me tell you what SD-WAN gives us. So the first and very important feature of SD-WAN is we can manage it centrally. Let's say I have a vManage over here. vManage is one of my controller in SD-WAN fabric. With vManage, I can connect multiple, we can have a configuration in such a way that we can configure multiple routers via this vManage. Not just configuration, we can also push the policy with this vManage centrally. So let's say there is one branch wherein I have to do the configuration. So what do I need is only one person on this site to do the minimum configuration on the device. Once the minimum configuration is done on this device, I will be able to access it via vManage. And once it is accessible via vManage, I can do entire configuration remotely. Apart from this, let's say this branch came across any issue wherein some link is down or some application is not accessible with this branch. I can do the troubleshooting as well remotely using vManage. So the first and the most important aspect of the SD-WAN was centrally manageable configuration and troubleshooting. Since the troubleshooting was also done remotely via vManage, the downtime decreases because we do not need to send anyone on the site, or we do not need to have anyone on the site. So if I have 100 branches, I cannot keep 100 network engineers on site. So with this SD-WAN, the the human efforts is reduced and you do not need any engineers on site. So SD-WAN also gives us this granular, this centralized approach. Apart from that, let's say I had 50 branches initially. Now I wanted to have 50 more branches. So the configuration was also difficult back in time, wherein we have to send engineers on each and every site to do the configuration. But with this, we already have configuration ready on the vManage. All we have to do is to push it on the new 50 branches. Once we do the configuration, as I said, we had to do the IPsec configuration as well earlier. As soon as we do the configuration, these routers automatically forms tunnel with each other. We do not need to do any other configuration on the SD-WAN fabric. It automatically does the forms the tunnel with each other. Apart from that, earlier, let's say I have this router in my branch and I have two links to it, MPLS and internet. This one is MPLS and this one is internet. This is my router. So earlier we do not had any function wherein we can do SLA based configuration on the router, on the legacy network, on the legacy router. But with the SD-WAN router, let's say I have some critical application hosted on the data center, which is also our hub site, and I want to access this critical application via MPLS link. We can do this configuration on the SD-WAN network, and this too we can do it remotely via vManage. Apart from that, let's say we have two links and the link quality of MPLS is good as of now, and we can define the SLA based on latency, jitter, and packet loss. Let's say I have defined a SLA policy wherein if my link's packet loss is 2% or above, the it should shift to the another available best link. So with SD-WAN we can do this configuration. So SLA and latency part was not available in the legacy network, which has been introduced in the SD-WAN. Apart from that, each SD-WAN device does the load balancing, equal cost multipath. So each SD-WAN device, if you do not have any SLA configured, it by default load balances on all the available links. So we do not need to do any other configuration for this as well. Apart from that, let's say there are certain applications that are being used by this branch, and those applications are Teams call, Outlook, YouTube, and Insta. If I want the Teams traffic to go via MPLS and not via internet, the Outlook traffic, these critical traffic to go via MPLS and not via internet, we can do this configuration in SD-WAN. So this application, this technology is called application aware routing, which is also possible with SD-WAN network. We earlier, when we go back in time, we do not have uh, any technology where we can do application aware routing. We used to have we can do IPSLA based on source IP, destination IP, source port, and protocol. Source port, destination port, and protocol. But with the introduction to SD-WAN, these things have been evolved. So we can do so many things via SD-WAN, and hence SD-WAN is very much demand into the network, and slowly and gradually every client is moving towards this SD-WAN approach. So one important concept about SD-WAN is, and this is also an interview question, which is what is underlay and what is overlay. So this is very important concept. Also, this is being asked in each and every interview questions. This is very basic of SD-WAN. So when I talk about underlay, underlay is nothing but, let's say I have this router. This is my branch router, branch 1, and this is my branch 2. And there are multiple routers in the path that is connecting these two branches. Okay. So each and every interface, the cables, the connectivities, and the routers are the underlay network. And once they provide the connectivity from branch 1 to branch 2, they form an IPsec tunnel. So this IPsec tunnel itself is overlay, and the connectivity that is being provided by the routers, the cables, the fibers, the interfaces are nothing but the underlay. So this is one of the important uh, concept, and it is also being asked in each and every SD-WAN interviews. So each and every SD-WAN network is divided into, SD-WAN fabric has four main parts. One is the SD-WAN fabric has four main aspects, four main parts. One is vManage. Second one is vSmart. Third one is vBond, and fourth one is edge routers. So vManage is nothing but the heart of SD-WAN fabric. vSmart is the brain of the SD-WAN fabric. vBond is nothing but an authenticator of SD-WAN fabric. And edge routers are of course the end devices, are routers. Okay. So in any of the SD-WAN fabric, no matter how big, how large, how critical it is, we will have only these four components in the network, in the SD-WAN fabric. Of course, we will have redundancy and all, we will have multiple vManages, but then we will have only these four, uh, these three controllers and and the edge routers. Now, vManage is responsible for managing the management plane of the network. Management plane. vSmart is responsible for managing the control plane network, and the edge routers are nothing but data plane. Okay. Now, what is management plane and what is control plane and data plane? All right. So let's say I have this router and I have a laptop over here. if I want to access this router from this PC, I will open a putty on this laptop and type the IP address of this router. Now, I will either SSH to this router or telnet. So the SSH packet that is being sent from the laptop to the router is managed by the management plane. Now, even if I do telnet to this router, the telnet as well is managed by the management plane. So the management plane basically handles the management architecture of the router. So even if I open a web browser and type the IP address of this router to access it via GUI, even those HTTP and HTTPS packets are handled by the management plane. Apart from that, if let's say there is a server and I want to monitor the health of this router using this server, I will do certain SNMP configurations on this router. I will provide the string, I will provide the IP address of this monitoring tool. Apart from that, I will give the source interface, I will give the key of this server. Now, this SNMP server, let's say it is SolarWinds. This SNMP server will send polling request to this router, which will collect the health of this router, the liveliness of this router. Now, these packets will also be handled by the management plane. So anything related to the management of this particular router will be managed by management plane of the router. I hope management plane is clear now. So what is control plane? Let's say there are two routers and they are connected to each other. This is router 1 and this is router 2. Let's say there is OSPF running on this router between these two routers. Now, as soon as we configure OSPF on these routers, they will start sending hello messages in order to form neighbor relationship. Apart from sending hello messages, once the neighbor relationship is formed, they will share LSDB data with each other. First, router 1 will share the LSDB data, then router 2 will share the LSDB data. Now, based on this LSDB data, each router will perform shortest path first algorithm in order to find the best route to the destination, and basis on which they will create a routing table. Now, all these packets that are being sent between router 1 and router 2 are handled by the control plane, not just with the OSPF. Let's say I have a BGP configured on both of these routers. BGP will also have their own BGP will also share the hello messages and go to the authentication. They will check certain parameters, then they will share the details of the routers which is present on router 1 and router 2. Now, these packets of BGP as well will be handled by control plane, be it EIGRP, be it OSPF, everything is handled by the control plane. And the end goal of the control plane is to create a routing table. Coming to the data plane. So what is data plane? Let's say I have a laptop, a PC over here, This is my internet. And I have a server over here. Now, and this is my server. Now, if I want to communicate with this server over internet, or let's say if there is any other PC on the similar network, and there is a switch in between, and if I want to communicate between these two PC, or between this PC to this, between this PC to this server, the packets that are being sent by this PC to this server and the PC over here will be handled by data plane. So data plane is nothing but routing the packets from the particular data packets from the particular source to the destination. So with non-legacy device, with non-SD-WAN devices, all these planes, be it management plane, be it control plane, and the data plane, used to reside on one single router. Earlier, let's say this is my router. The management plane, the control plane, and the data plane used to reside on the router. But with the SD-WAN, that is not the case. The management plane has been removed from this router and put it onto the vManage. The control plane from this router has been removed and they've put it onto the vSmart. So the management functionality is now a remote rights of vManage, and the control plane functionality is being handled by vSmart. So only data plane resides on the router, due to which the productivity of managing data plane has been improved. Okay, now there are, in order to have a proper network topology which is up and working, they need to get the management plane details from the router, from the vManage and the vSmart. So they form a DTLS tunnel with the vManage and get those details. Apart from that, they need to have the routing details as well. So they form a DTLS tunnel with the vSmart and get those details. But before doing this, there is also a vBond authenticator, which works as an authenticator. No matter what, which SD-WAN device it is, we need to authenticate each and every device with the vBond before being added into the SD-WAN fabric. These vManages, be it vManage, be it vSmart, or be it vBond or the edge routers, they need to authenticate with the vBond, provides their authenticity, and only then they will be added into the SD-WAN fabric. So these three are the controllers of the SD-WAN fabric, and this is the edge router. So vManage, vSmart, and vBond, these are not physical devices. These are virtual devices. So when I talk about vManage, vManage is a virtual device we can host this vmanage. I mean 90 to 95% of the client are hosting this vmanage on the Cisco cloud. So Cisco cloud is responsible for the the backups, for the redundancy, for the uptime of this vmanage. So this is the Cisco cloud's responsibility. But if there are any other clients that is hosting this on the network, they need to host it on the servers or on the virtual machines. Okay. Now, to host this on the vmanage virtual machine or on the servers, we will need some sort of images, and this images we can either get it from the cloud, from the Cisco. There may be two types of images, .ova and .qcow. Depending upon the VMs or the servers that you are hosting, we will have to provide the OVA or QCOW to images to the VM team so that they can install this vmanage on the servers. With one vmanage, we can manage up to 2000 vNage routers. As I said, that this Cisco Viptela is designed for large network. So with one vmanage, we can manage 2000 WAN devices. Apart from that, for redundancy, we need to have at least two vmanages. So two vmanages is suggested for the redundancy purposes. Okay, and with this vmanage, we can have a GUI access and do the configuration of the devices and troubleshooting. Similarly, with this vmanage, as I said, we will also be able to upgrade and downgrade these controllers and the edge routers. So if, let's say, if I have to upgrade my controllers to the latest new version, we will be doing it with the vmanage itself. Let's say if I have to upgrade the controller, that part is also being taken by the vmanage. Let's say if I have to upgrade the vbond and the edge routers, we will do it from the vmanage itself. With vmanage, we will have two types of access to it. One is via GUI and the other one is via CLI. Coming to the other controller, vSmart. vSmart is again a virtual appliance, a virtual device. There is no physical device of vSmart available in the market. We will either have to host it on the cloud or on the on-prem. So for cloud, we can go for Cisco, AWS, GC, Google Cloud. And if any of the client needs to host it on-prem, again, we will need two types of images. One is OVA and the other one is QCOW. Depending upon the VM and the servers, we will provide the images, the files to the VM team, and they should be able to do the configuration from the VM server, the VM, and then we will be having the access to the vSmart. With vSmart, we will not have GUI access to it. We will only have CLI. We can have multiple vSmarts for redundancy purposes. At least two vSmart is suggested by Cisco, so that we will have at least two vSmart for redundancy purposes. The main role of the vSmart is to provide the control plane functionality to the edge routers. So with vSmart, once the tunnel is up between the branches and the vSmart, vSmart is responsible for providing control plane functionality. Apart from that, it is also responsible to provide IPsec keys. As we discussed earlier, as soon as we do the configuration on branch routers, they form DTLS tunnels with each other, right? So in order to form a tunnel, in order to form an IPsec tunnel with each other, they will need some sort of configuration, some sort of data, some sort of keys. Those data, those keys are provided by vSmart to each of the branches so that they can form the tunnel. And we do not have to do any manual task. As soon as the branch routers form the connection with the vSmart will give them the data that is needed to form the tunnel, and they will form the tunnel. That's it. And that is why SD-WAN is one of the leading technology in the market as of now. So what is vBond? vBond is nothing but an authenticator. This is one of the important controller on the SD-WAN fabric. So whenever we have any edge routers or any controllers that is deployed, it first have to authenticate. There needs to have some sort of authentication to add any of the devices, right? Let's say if there is no authentication and any hacker that tries to communicate with the vBond and get all the details about the vSmart, vManage and the edge routers, that is not desirable. So in order to have authenticity, authentication, security of your SD-WAN fabric, vBond is required. Each and every device is first authenticated with the vBond. There are certain authentication, what sort of authentication is done, we will be discussing about that in detail in later part of the course. But as of now, in order to in order to get added to the SD-WAN fabric, each and every controller and the WAN edge routers needs to authenticate with the vBond. Once they are authenticated with the vBond, vBond is responsible for giving the providing the vManage and the vSmart IP details to the routers so that they can communicate with the vManage and get the configuration and start the monitoring of these devices. They can, so that they can communicate with the vSmart and get the control plane functionality, start forming the tunnels and have network reachability. So this is the main role of the vBond. So let me take you all through the vManage. Let me show you all about the vManage. So this will be our lab wherein we will be doing the labs. So this lab is hosted on Google Cloud. These are the hubs. Those who have attended the demo sessions might be aware about it. So this is for the ones who have not attended the demo lecture. So this will be the hub site wherein, so this is the cloud wherein we have hosted our controllers. As we said, there is one vManage which manages the management plane, vBond, and two vSmarts. We also have Linux machine wherein we will be taking the GUI access of the vManage using this Linux machine. This is the branch network, and this is the hub site. Each branches and each hub site is having two connections, two WAN connections, one with the MPLS and other with the internet. Each branches will be having two configurations. Similarly, vManage, vBond, vSmart will also have two connections, one with the MPLS and other one with the internet. Likewise for the hub site, one with the MPLS and other one with the internet. We will be having a default route configured towards internet, and we will be running OSPF between branch routers and the MPLS connectivity. And with the internet, we will be having a default route, static routing. This is the LAN segment wherein we will be having OSPF. OSPF will be running on the LAN segment of the network. Now, the configuration of vManage, vSmart, vBond, we will be, each and every student will be building their own lab and we will be assisting them to build their lab. And each and every configuration will be done by each and every student so that they have access from day zero, so that they can have access from right from the scratch. They will have the access to build the entire network. Okay, so what configuration is required for branch side, what configuration is required from the LAN side, what configuration is exactly needed for these controllers, each and everyone will be having a very in detail hands-on experience. Okay, so let me take you all through to the vManage graphical user interface. So this is how the vManage graphical user interface looks like. As I said, it is responsible for the management plane. Now we can see that it is monitoring the vSmarts, it is monitoring the VNCPH routers, it is monitoring the vBond as well. We can see how many connections from this VNCPH is up. As of now, it is showing 4. So if we go back to the topology, we can see 2 of our routers are turned on and it has 1, 2, 3 and 4 WAN links. So that is what it is showing over here as well. 4 WAN links. Apart from that, since it is responsible for the management plane, we will also be able to go to the network and have SSH and GUI access of each and every device. Once we go to monitor network, we can click on any of the router and see their environment statuses. We can also execute the commands from here, and so on. We will also be able to see the alarms if there is any alarms that is generated. As of now, there are no alarms since I have recently built this lab. So as of now, there is no alarm. So you will be able to see the alarms. You will be able to see the events from this particular section. So it shows loading now. There shouldn't be much events as the build lab is built fresh. You can also see the logs from here, but as of now, there will be no logs. So this is just to give you all an overview about the vManage graphical user interface, how exactly it looks and what are the tabs that are available. So we can view the devices and the controllers from this tab. So these are the devices and these are our controllers. We can see we have one vManage, one vSmart, two vSmart and one vBond. And if we go here, we can see there are two devices that is live as of now, which is Dubai and London. So there are certificates as well. The certificates, as I said, before authenticating with the vBond, the edge routers needs to provide their certificate to the vBond for authentication. So here is where we can see about the certificates. And there's much more we will be discussing. We will be going through each and every tab later on in this course. And there are, if we talk about the device models, there are two types of devices. One is Cisco devices and the other one is Viptela devices. The edge routers, there are two types of edge routers. One is Cisco and the other one is Viptela. And these will be physical devices, physical WAN edge routers. So if I have to tell you about few models about Cisco devices, it will be C1121X, C111X model, C411X model, and so on. We can also have ASRs and all. Apart from that, if I talk about the Viptela routers, there will be VH100, VH1000 series, VH2000 series, and so on. So these will be the physical devices. These edge routers will be physical devices. All of this will be physical devices. And we will also be having redundancy about this. If I have to show you about the lab, as of now, there is no redundancy, but when we move on later in the course, we will also add a router over here and do the redundancy part. Let's we also have a notes over here. Let's head towards the notes and see whatever that we have discussed today. Okay, so we have discussed about the SD-WAN, and you will also be getting these notes once the session is over. Okay, so we have discussed about the SD-WAN today. What is SD-WAN and why it is required. As we discussed that there are two types of SD-WAN solutions that is provided by Cisco. One is Meraki and the other one is Viptela. So as we discussed, Meraki is for small and mid-size SD-WAN solutions, and Viptela is for large-scale enterprise levels, as each vManage can have 2000 managed routers. We have also discussed about underlay and overlay, which is also an important concept and also being asked in each and every interview. So we have also discussed why SD-WAN was introduced. Earlier, we had leased lines wherein we had to connect one branch to other branch via physical connectivity, and why we moved from leased line to the leased line and other features to the SD-WAN, since it was very expensive. It was very difficult to trace and resolve, and hence we moved away from the leased line feature towards the SD-WAN. The other important technology is also MPLS, and MPLS we are still using it in our network. It is, even though it is of high cost, but still it is very much important in the industry as of now. We also discussed about why we moved away from internet because of its low security and no SLA. Since there was no security and SLA, we moved away from it. We also discussed what is IPsec and why we have moved away from IPsec to the SD-WAN. Since there was no SLA part with the SD-WAN, and apart from that, since there was no SLA, there was no critical delays and no issue. I mean issues with the critical delay sensitive applications, and hence we moved away from the IPsec to the main SD-WAN technology. Talking about the SD-WAN technology, SD-WAN advantages, we have discussed about the SLA and the latency part, wherein how we can define, let's say we have this branch and two connections, with one with MPLS and the other one with internet, how we can define SLA on this router so that it can decide which link has better connectivity, better SLA, and decide which link to use to reach to the critical delay sensitive servers and applications. So we have already discussed about this as well. Apart from that, we also discussed how we can manage the edge routers centrally, how we can troubleshoot it, and how we can do the configurations and troubleshooting centrally by sitting simply at the hub site to all the branches. We have already discussed about this. And apart from that, we have also discussed about the scalability and the security. How, let's say, for example, we have 10 branches as of now. And if we want to increase the sizes of the branches to 50 more branches, how we can do it with few clicks, how we can scale it to from 10 to 50 sites just in few clicks. So we have already discussed about this. We've also discussed about the configuration, how we can simply create one template. So there is one feature in SD-WAN wherein we can create feature templates. So when I talk about feature templates, let's say I want to do a TechX configuration for 50 branches. The TechX configuration for all the 50 branches will be same, right? Since we will be using only one TechX. So in rather than logging into each and every branches and doing this TechX configuration, what we can simply do in SD-WAN is we can create one feature template, add it onto the device template, and with that device template, it will be pushed to all 50 branches at once. So if I have to do this TechX configuration for 50 branches, one branch at a time with non-SD-WAN feature, we will at least need 10 minutes per branch for logging in, to do the authentication, to do the checks and all. And with SD-WAN, you can do this configuration on each and every 50 branch, not more than 10 minutes. It is as simple as creating one feature template and pushing it to all the branches. So this is how we have improved with SD-WAN and why SD-WAN is necessary in today's world. With SD-WAN, we can also save cost, wherein let's say we have a branch and it does not need to communicate with critical sensitive application. So in this branch, what we can do is we can have two internet links. Instead of having MPLS links, we can have two internet links and do the SLA configurations. So whatever link has the best SLA will be preferred. And by doing this, we will be able to save the cost of the company. So that is what we have discussed over here. As I said, with SD-WAN, we can also do load balancing. As soon as we do the configuration on the SD-WAN router, it automatically starts doing the load balancing using ECMP. We have already discussed this. We've also discussed about the application aware routing, how certain specific applications can be preferred over MPLS link and how other applications can be preferred over the other internet link. Earlier, we used to do it via policy-based routing, which is a lot of configuration on each and every devices. Today, we have also discussed about the controllers, which wherein the control plane is responsible for managing. vSmart is responsible for managing the control plane functionality. We have also discussed about this. So we've discussed about the control plane, management plane, authentication, and apart from that we have also discussed about the data plane. So with management plane we have discussed how management plane is responsible for managing the SNMP, telnet, SSH packets. The CLI access is managed handled by management plane. We have discussed about this. We have discussed about the control plane as well, how it handles the OSPF packets, BGP packets, EIGRP packets. Apart from this, it not only handles the routing packets, but it also handles HTTP, ARP, and DHCP packets. And of course, data plane is responsible for handling net table, access lists, ARP table, and all. Apart from this, we also discussed about the controllers today, how that there are three controllers: vManage, vSmart, and the vBond. we have discussed about the vManage controller, that we need to either host it on the cloud or on the servers. And 95% of people are using cloud options. And with the cloud options, we can go for Azure, AWS, or GCP. We've discussed that each VNedge routers can manage 2000 VNedges. Each vManage can handle up to 2000 VNedge routers, and we can have a cluster of 6 vManages in the network. So let's say I have an organization which has 4000 VNedge routers. So for this 4000 VNedge routers, this cannot be managed with one vManage. We will we will need at least 2 or 3 vManages, and it is always recommended to go for 3, because each vManage can have 2000, each vManage can manage up to 2000 manage routers. And if we go with 2, there will be no breathable space for vManage. So it is recommended, if we have 4000 or more, go for 3 vManages. Similarly, with 6 vManage, we can manage up to 12,000 manage routers. So one SD-WAN orchestrator can manage up to 12,000 branch sites. That is a very huge amount. Imagine having a 12,000 branches, and that is being managed by one SD-WAN fabric. You can simply log into one vManage and manage these 12,000 branches. Apart from that not only we can do the configuration and troubleshooting, we can also do the upgrades and downgrades of the WAN edges as well as the controllers with this vManage. And of course we can also push the policies on the vManage using vManages. So we have also discussed about the vSmart, how it manages the control plane functionality. Similarly, it is also hosted on the cloud, and if anyone wants to host it onto the premises, we can use VM or the servers. So we have also discussed how control plane information, the routing table, the crypto key is shared from vSmart to the vManage. We've also covered this. So when we talk about the vSmart working, as soon as this router, as soon as the router gets the details about vSmart, it authenticates itself and forms a tunnel with it. And post authentication is done with the VNedge to the vSmart. It will share the crypto key, the control plane functionality, so that they can the IPsec, so that they can form the tunnel with the other branches. We have already discussed about this as well. Apart from that it also forms an OMP peer with vSmart, and under that OMP protocol it shares all this information. So that is what it is listed over here. Okay, so with vBond controller, we have also discussed how and where to host this VM controller. We will be hosting it on the AWS or the any of the cloud. Apart from that, we can also host it on the on-prem using VMwares or the servers. So vBond is the first point of contact to any of the edge routers or to the controllers. So let's say we have a non-SD-WAN fabric and we are starting to develop a SD-WAN network. So as soon as we configure any of the controller, the first point of contact to any of the controllers, when I talk about controller, I'm referring to vManage and vSmart. So the first point of contact to these controllers or to the edge routers is vbond. They will first reach out to vbond and do the authentication, and only then they will be added to the SD-WAN fabric. So vbond is the first point of contact to any of the controllers or to the edge routers. We have discussed about the on-prem hosting and the cloud hosting of all the controllers. So 90% of the customer uses Cisco hosted controllers, so that they provide the redundancy, SLA and everything about the controllers. And it is also the recommended method to go with the cloud hosting. So when we talk about the VNedge devices, we have discussed there are two types of VNedge devices. One is C-Edge and the other one is V-Edge. We have discussed about the V-Edge models and the C-Edge models and how it handles the data plane. And it is a physical device, not a virtual device. And here I have listed few of the V-Edge models and the C-Edge models.